The volume of air that's needed to keep up with those leak rates, the air compressor has in abundance. Okay, so it'll only run for when it's just an air compressor, right? The air compressor that's been filling dry systems for the past 40, 50 years, it sees that 3 psi leak rate or 10 psi leak or whatever in this system or in several systems or whatever. It's going to run and only run for a few seconds because it's throwing 15 CFM at it, which is overkill for very, very small leak rates. It's exactly what you need for your fill, but you need a lot less air volume for your leaks.
Right.
Okay? The problem and the reason that people are talking about leak rates now is because that abundance of air, that abundance of volume to fill your system with is not there when you're talking about a nitrogen generator. Because now, a nitrogen generator, we're taking the air compressor and we're attaching a fancy filter to it that when we get on the other end of that, we're getting 98% nitrogen. So, I mean, really, it's like, we've been saying it's an air compressor with a filter on it. So you take your air compressor, the air goes out of the compressor, it goes through some pre-filters to clean the air out, and then it goes into the nitrogen membrane. As it goes into the nitrogen membrane, it takes time and pressure for the oxygen and nitrogen to separate, okay? And time and pressure are the enemies of flow, so we're not just flowing that air right into the system.
Right.
We're stuck in the membrane in order to make that 98% nitrogen. The longer the air stays in the membrane, the higher the percentage of nitrogen.
Right.
So if you wanted, 95% nitrogen, you'd be into that membrane for a lot less time and you get a lot more flow out of it. But the industry standardized on 98%, so we take a little bit more time in there. And so what happens is if you get, say, 15 CFM out of the compressor, you're going to get a fraction of that out of the membrane at 98% nitrogen.
Right.
So we lose all that flow, and now we're talking about, say, half of a CFM. Well, keeping up with the standard air leaks that NFPA calls out and stuff like that, keeping up with those air leaks with an air compressor is not a problem at all.
Right.
But because you have 15 CFM or you have 5 CFM, you have the full power of the air compressor behind it, right? You don't have the full power of the air compressor behind that when it's on a nitrogen generator, because now you're losing your flow in the membrane and you're dealing with a fraction of 1 CFM at that point. And, as the system grows and it starts to leak more and more, that unit is going to be running and running and running, trying to keep 98% nitrogen in there at a fraction of a CFM, as opposed to an air compressor that's going to be running just for a few seconds to keep it full with, at its full flow, say 15 CFM or whatever, of just standard air. Now, granted, the standard air is going to cause corrosion, the nitrogen is not. So you got to kind of weigh all these, issues. Sure. When you're doing this. I mean, how bad is your corrosion problem?